Hello everyone. After the last tutorial about sending values from your PCG to your blueprints, some of you have showed interest into learning how to do the blueprint that I made for creating this parking spot with the numbering system. So you can see that you can control the number drawn in the level with this variable here, number, in the blueprint, and this variable is passed to a decal material that is pasted as separate decals for each of the numbers. As you can see right now, all these different numbers are a separate decal. So this number then can be changed with different color, with the variable for the color, and you can add different variables, for example, for the size or for the roughness of the material or whatever you like. The important thing is to understand how to pass the values from the blueprint to your material and how to spawn different numbers for the value that you have entered. So this is done by a couple separate type of objects that we need to create. First, you need a texture with all the digits taking 1/10 of your texture. So each of the digits is 1/10 of the texture. So after having this texture, make sure that you have an alpha value that's used for the transparency. So I can show you that this texture has just a black color for all of the numbers, and then the alpha value is controlling what is visible or not. The color doesn't really matter if you're doing a single color like I am. If you want to have some gradients in your numbers, you can have the color fading from white to black, and you can multiply then this by the color variable. But for simple numbers like I showed you, the color doesn't really matter. You will only use the alpha channel. Okay, so let's close this and check the other parts. So the next thing that you'll need is this decal material. So we'll create a material that shows the number based on the variable that's used to decide which number to show. So let's open the material and make a quick overview. So it may look a little bit hard to do if you're not used to materials, but actually the whole part here at the bottom is just to make this worn out look. So if we disconnect this, let's connect the texture directly. Let's disconnect this. So this is the everything that you need for this material. You can have the worn out look in your texture. I have solid numbers and I'm then applying the worn out look from other texture just to have more control. But you can totally do this only with the texture. So the important thing here for the material is to be of a type deferred decal, and the blend mode should be translucent. This will allow you to control the opacity. And the color, as you can see, is created as a parameter connected to the base color of the material, and we are using the alpha channel of this texture. We are subdividing this texture into 10 different textures with this sub UV function. This is a default function in Unreal. And we are dividing it into 10 textures with these values of 10 and 1, horizontally 10 and 1 for the vertical axis. And this number is controlling which part of the texture we are seeing, and you can see that if I change the number, it's changing the appearance of this decal. So let's save this. Actually, let me reconnect back this to have the same look as before. I'll show you how you can recreate this material. I'm just doing an overview now of everything. So the next thing after you create this material is to make a blueprint. And in this blueprint, you have an input value for the number. And because the decal that we created is only drawing a single digit, we need to separate the number that we are inputting into different digits for each part of the number. So for 25, for example, we need 2 and 5. And this thing is done here by adding separate values into this digits array. I'll show you later how it's done, but basically you are taking the last digit of your number and adding it to this array, and then taking the number without this last digit and continuing until no more digits are left. And after you have separated everything into this digits array, we'll reverse it because we'll draw it from right to left. And then for each of the digits, we'll create a decal, we'll place it, and then we'll set the material and the different variables that we need into this material. And this is the whole idea into our blueprint and decal, to create material that accepts variable and to create the logic into our blueprint how to send this variable into our material. So let's start now by creating first the material, and you'll see how everything is being done step by step. So let me delete this from our level, and let's start by creating a new material. So right click into your content browser, write material, create material, and call it decal number, for example. Let's open this material. And first, let's make sure that this material is deferred decal type, and the decal material is only visible on other objects. So let me change the type to translucent, and you will see that it disappears. Let me import now the texture that we had. So make sure that you create similar texture. So this is the texture with our digits. If I connect the alpha output of this texture into our opacity value here, and let me change the preview mesh to a cube. So now we have a cube. Let's rotate a little bit down to see what we are seeing. So currently we cannot see anything into our level. So let's start by changing this color with a parameter. So let's promote this base color to a parameter, and let's have a default value of white for our text. Okay, so now you can start to see our decal in the level here. I changed the preview mesh to cube because the default one as a sphere is distorting the numbers, so it's a little bit easier to see with a cube. So click here at the icon that's before the last one. So right now you can see the alpha channel of our texture is controlling the opacity of the decal, and the color parameter is controlling the color that we see for the numbers. Let's now make this texture as a 10 separate texture with the subuv function. So this subuv function, it accepts the texture as a parameter. So unfortunately this texture sample is not compatible with this texture 2D node. So instead of texture sample, which is automatically created when you drag the texture into your material, we'll need to do a texture object instead. So right click here, write texture object, and create a texture object, and choose the same texture as we had here. So this will be our numbers texture. So let's apply and save this. So after you have the texture object, you can connect the texture object to the texture input of the subuv function. Then hold the 2 key and press into your level. This will create a vector with 2 values or 2 scalar values. And the first one is how much you want to divide your texture in the horizontal space. So we want 10 divisions, and into the vertical space we want single division. So we'll input this into the sub images, and then we'll create another single scalar value. So hold the 1 key and click into your graph, and this will be connected to the frame. So after you have this setup, connect the alpha to the opacity. So right now you can see, after the material has been compiled, that this number that we input here is controlling which of our 10 images is seen into our material. So this is exactly the setup that I had before. So let's delete this texture that we had. So this material is enough to show you how you can control it from the blueprint. You can add the other part by multiplying this alpha by some texture that you have. So for example, let me go into my level here. This is the paint chips texture that I have. So I can multiply the value of my number here, the alpha of my number, with some texture that I imported, and you can see that it starts to take away from the number and it seems like it's worn out. So I'm combining these three textures to make a single texture that is controlling the worn out look of my numbers. But you can create any texture to do this and just input it here into the multiply. So I will not be doing this, so we can have a simpler graph right now, and you can create any look you want into your texture directly. It doesn't need to be added later. So let's continue now with creating the blueprint that will hold these decal numbers. So let's save this and let's go back into our folder here. Right click into our graph, create a blueprint class. This blueprint class will be actor type, and let's call it blueprint decal number, for example. Let's open this blueprint, and because this decal is not visible if it's not over any object, I'll add a cube into my level. So click on the add button here and add a cube, and this cube I'll scale a bit so we have more area, and I'll move it vertically so it sits just under our scene root. Let me reduce the scale into the Z direction. So we now have a big cube which is sitting at our grid level, so we can see the decal when we place it. So let's change this material to something darker. Let's choose the basic template material. Let's compile and save this. And now, if we add our decal here, so let's add a decal. Let's move it into the scene root. So this decal, let's change the material of this decal to the material that we just created. So M decal number. You can see that it's rotated the wrong way. So we need to rotate it minus 90 degrees in X and Y, and you can see that now it's being properly placed into the level. This is a bit big for my taste because this cube is 10 meters long, so it's a huge cube. So let's reduce the scale of this decal to 0.2. So we have a smaller number. You can reduce it even further later, but for now, let's do it like this. So let's compile and save. So this shows you how the decal should be placed into your level. So these values are important for later. That's why I placed it in the level. We will not be having this decal into our level like I have it now. We'll created dynamically based on how much numbers, how much digits do we need to draw our number. But this way you can place all the decals that you want into your blueprint. For example, for my parking lines, I had 2 decals for the parking spot lines. So for example, this one, I'll scale it a bit. And the other one was just a single line. So after you're happy with the placement of your decals, you can remove this cube, or you can leave it for now just to be easier to see what we are doing in the level. So let's compile and save everything. And let's go into the construction script of our blueprint. So the idea is that we want to enter a value. So here into the variables, let's add a variable to input our number. So let's call this value number, and it will be an integer type, and it should be public so we can enter it from our level or from our PCG scripts like in the previous tutorial. So let's add another variable, which will be the color that we want to have for our decal, and the type here will be color, of course. This should be public as well. So let's compile and save this. Just to demonstrate you what we'll do, let's do just a simple change into our current setup right here. So if I place, let's delete this cube, so I can place the decal into my level, like this. So if I place the parking spot into my level, I want to be able to control the number and the color from the values here. Currently they are not doing anything. This is just the default value of my material. So let's go back to the blueprint. So this decal here is the decal containing the numbering into our level. So let's drag it here. Let's create dynamic material instance. So in the construction script, everything you do, it will be executed when you put the blueprint into your level or when you change any value of this blueprint. So you will immediately see the changes in your level. If you put your logic inside the begin play, it will be executed only when you enter your game. So the construction script make it easier to see into the editor. So that's why I'm entering everything into the construction script right now. So let's connect this. When you create a dynamic material instance, you can then set scalar parameter value for this instance. So drag out of the return value here and set the scalar parameter value. And the parameter name should be the same as in your material. So let's open the decal number material. Let's check the parameter name that we have here. Currently the name is 1, which is not a very good name. Let's convert this to a parameter and call it number. Let's change this to color, or base color will be better. So we have a number parameter and a color parameter. Let's apply and save this material. And if we go into our decal number, now we can set the number parameter with the value that we have entered for this number into our blueprint. So let's connect it here. And after this, but this time it will be a vector parameter. So let's drag out of this return node, set vector parameter value, and this vector parameter will be our color. Parameter name will be color, and we'll connect our color value here. So this is the simple graph that we need just to show a number into our blueprint. And next I'll show you why we'll need some changes and make it a little bit more useful. So right now I have the number here. Let's add number 1 and let's change the color. So let's do a yellow color just to prove that it works. So if I change the value into my blueprint, it's then passed into the construction script to my dynamic material instance. And it's working for all the digits from 0 to 9. But if I do 10, 11, 12, it's just working with the last digit here. So we need to fix that. That's why I had a little bit more complicated logic, as you saw in the blueprint demonstration before. So let's go into the decal numbering. So the important thing is that this way you can set the values for a dynamic material instance. And what we'll do here is we'll not have this decal into our level. I'll delete it. We'll only have the lines for our parking spot, and we'll create the decal automatically based on the number that we entered. So first, let's get the number that we entered. Let's do a while loop. Let's check if this number, actually not this, will create a new temporary number. You can create it as a local variable to be sure that it's used only in this graph. So let's create a input number variable, and the type will be integer, the same as the number that we have here. So let's set this input number. So I'll drag this input number into our graph, connect it like this, set it to the number value. And this is our starting number that we want to use for our while loop. So control drag this input number, check if it's bigger than 0, and connect it to the condition here. So if this input number is bigger than 0, let's disconnect this and move it for now a little bit down. So if this number is bigger than 0, we'll loop through each of these digits by first adding this last digit of our number to an array. So first let's make an array into our local variables. Let's call it digits array. It will be of type integer, but it should be an array, not a single integer. So let's choose the type array here, compile and save this. So let's control drag this array here. Let's drag out of this array and add an element into this array. So we'll add first the last digit of our input number. So how to do this? Let's drag our input number into the level. Let's do a modulo operator. So this modulo operator is marked by this %sign. So this means that we'll divide by the number that we enter here at the bottom, and the remainder of our division will be returned here into the return value. So if we divide by 10, if our input number, for example, is 31, if we divide by 10, it will return a result of 1, because 31 cannot be divided by 10 as a whole number. We are having a remainder of 1. And this remainder is what this node will return. So let's connect this to our addition of an element into the array. So that way we'll add the last digit of our number into this array. Then we'll divide this input number by 10. So this time we'll do a divide. We'll divide again by 10. And we'll set our input number, so out drag the input number to this new result here. So for example, if it's 31, we'll return here 1, we'll add it to the array. Then after we divide 31 by 10, the result will be 3, and we'll set it as a new input number. This input number will be now a value of 3. We'll go back here, we'll check if the input number is still greater than 0. It is, because it's 3. We'll go into the loop body again. This input number modulo operator by 10 will return 3 now, because you cannot divide 3 by 10, and all the whole number will be returned as a reminder value. We'll add this to the digits array. We'll continue by dividing the input number by 10, which will return 0. And when we check this input number greater than 1, it will no longer be greater than 1, so it will not continue through the loop body, it will go to the completed pin. So when we complete this while loop, let's do a print string note, for example, and let's print the value of our digits array. So let's get the digits array, drag it into the level, choose the get, and connect it into the string. You cannot connect the array directly, so let's do a for loop. For each loop, let's connect this for each loop into the completed pin, and then for each value of our element, we'll print the string into the level. So we'll convert this integer to a string and we'll print it to the screen. So let's compile and save this. Let's now change the value to 51, for example. And unfortunately, you cannot see this print string into the level. But if we go into the output walk, you can see that we have the values 5 and 1 printed. Let's change the input of this array to, for example, 158. So when I change it, if I open the output walk, you can see that here we are outputting 1, 5, and 8. So our digit array contains the 3 digits for our number that we entered. And if we want to draw our number, we want to start from the last digit that we entered. So this 1 is the last digit. That's why I'm reversing the array. So first, let's reverse this array. Let's connect it here before this for each loop. So after we reverse this array, let's connect it like this. Let's move everything a little bit here to the right. And now let's continue with the dynamic generation of the decal and the material. So let's delete this print string. And for each digit, we'll create a decal dynamically. So drag out of the loop body pin here, add decal component, and this decal component will save into another variable. So let's create another local variable called decal. We'll do the type decal component. We'll create another variable here. It will be material, and the type will be material instance dynamic. It's what it's called here. So let's compile and save this. And now let's save this generated decal into this decal variable. So out drag the new decal variable, connect it to the execution pin, connect the generated decal to this variable. So now we are saving the decal into the variable. Let's set the relative transform of this decal to the values that you remember we were setting before in our blueprint. So let's split the transform pin and let's set the scale to 0.2, the rotation to -90 in X and Y axis, and let's leave the translation for now. I'll show you later what we'll do with the translation. So after we create the decal and we rotate it and scale it to the proper position, let's then create a dynamic material instance. So let's drag out of this pin here, create dynamic material instance, and the parent material will be the one that we created, so mdecal number. So from this mdecal number, we'll create a dynamic material instance, and let's save it into this material variable that we just created. So we have the decal and the material saved into the variables. So let's use these variables. First, let's set the material to this decal. So drag out of the decal and set decal material. And we'll set this decal material to the newly created one. Let's now drag out of this material and set vector parameter value, and do it again to set scalar parameter value. So the scalar parameter will be our number and the vector parameter will be our color. Let's connect this. And the values that we want to set is the array element of our digits array. So for the element that we are doing this for loop, we'll save it into the scalar parameter value here. Let's rearrange the nodes to be a little bit more easy to read. Like this. So we are saving the array element from our digits array into this number parameter for our material. And you saw earlier that if you set the number variable, we are properly displaying it into our level. And we'll save the color inside this vector parameter value for the color. So in this way, if we compile and save this material, if we go into our level, you'll see that we now have all the numbers that we added. So let's say we'll do 21 or something more obvious, 24. So you can see now we have both numbers, but they are stacked on top of each other. And to avoid this stacking, let's go back into our blueprint and let's add here some logic for the transformation. So let's split this pin. We want to transform our values in our decals, into the Y axis. So we'll multiply the index that we are currently into this array. So drag out of the index, choose multiply, and we'll multiply it by 40, for example. Let's connect it now to the transform Y. Let's compile and save this. And you can see that we start to place our numbers separately from each other. So I have entered 24, but they're rendered as 42. So this should be a negative number, not a positive. We need to move negatively in X, and let's change the value here to -80 because we need more space. Let's compile and save now. And now you can see the numbers are properly placed as we entered them here into our blueprint. So let's do 1852. They look fine. Maybe we can reduce a bit this to 70. And what we want to do is not to have our first number always on the same place and then move all the others. We want to move the full number based on the size of the number. So let's add to this position here. We'll get the length of this array, so how many digits we have into our number. We'll multiply this by half of the size that we're moving them, so minus, actually this will be the positive direction, so positive 35. Then we'll add this numbers together. Let's connect it like this. And now if I compile, you can see that the number will be always centered to the location. These numbers, of course, if you want to have the control over the scale of the decal, you need to also modify this number that you're using to control the position. But you can easily do this by entering a new value for the scale. Let's say this will be a float type value. And here, actually it will not be a local variable here. It will be a variable exposed as a public variable. So let's add it here, scale or decal scale. Let's do the default value of this to 0.2 as we had it before. So here, this decal scale will connect to the transform scale. And this number, minus 70, because we had the scale of our decal as 0.2, we need to make sure that if we multiply decal scale by 0.2, we'll get 70. And then we'll multiply only by minus 1. So to get 70 by multiplying to 0.2, you need to have 350. So let's control drag from our decal scale. Let's multiply it by 350. And I got this number basically because 0.2 is 1/5 of 1. And this means that I need to multiply 70 by 5. So this is why I get 350. So this decal scale multiplied by 350 is the value that we want to multiply our index with, and we'll add another pin and enter -1 here. And for the positive moment of the whole number, we'll again multiply by the same value, but we'll add 0.5 because we wanted half of this number. So this cannot be 0.5 because it's currently an integer, so right click and convert this to float, and then you can enter 0.5. So this needs to be float as well, but you can just convert this to float and then add them together like this. So let's compile now and save. And if we go back to the level, you can see we have the exact same result. Actually, the numbers are not moved. So let's check here. So we are multiplying the index by this decal scale. And we are moving it back. So this should be converted to float as well. Let's convert it here as well. Now everything should work fine. Okay, now it works fine. We had a problem with our calculations because we cannot have float numbers in our integer variables, but now everything is fine. So now you can see that you can enter any number here, and if you change the scale, it will change the amount that we are moving the numbers. So this is everything that you need to create any blueprint that has this logic for numbers inside it, drawn by these decals. So I hope you like this tutorial. I hope it helps you to make your levels more rich and dynamic. And if you have some questions, please write in the comments. If you like my tutorials, like this video and subscribe to the channel. You can join the channel, and in this way you'll be able to watch the tutorials earlier, and this will help me a lot to continue making them. So guys, I'll see you in the next one. Bye!